Welcome back to the deep dive. Today, we're unpacking a story that, honestly, I had to put the source material down a few times while reading this. It is equal parts inspiring and just, well, absolutely infuriating.
It really is. It's a heavy one today.
We are looking at the life of Niels Henrik Abel. And just to frame the stakes right at the top here, we are talking about a guy who revolutionized mathematics before he could even grow a full beard, but who died believing he was a total failure.
It is the ultimate tragedy of intellect versus circumstance. And to give you a sense of the scale here, consider this quote from the French mathematician Hermite. He said Abel left enough work to, and I quote, keep mathematicians busy for 500 years.
500 years. And the guy died at 26.
26 and 8 months, to be precise. I mean, it's unfathomable.
We're pulling this from E.T. Bell's classic book, Men of Mathematics, specifically the chapter titled Genius and Poverty. And I have to say, the tone of this source material, it's not dry history, but Bell writes this almost like a Shakespearean tragedy.
It fits, doesn't it? You have all the elements. You have this, wicked schoolmaster crushing poverty, lost manuscripts.
And a letter that arrives exactly 2 days too late to save his life.
Exactly. It's gut-wrenching.
But before we get to the tragedy, we have to understand the genius. Our mission today is to explore how this young man from a freezing, poverty-stricken village in Norway managed to change the world. And specifically, we're going to drill down into this mental model he used called inversion.
Yes. Inversion is the key. It's not just some math trick. It's a way of thinking that I think anyone listening can actually use.
So let's set the scene. Norway, 1802. This is not the wealthy, oil-rich Norway of today.
Oh, far from it. It's a bleak picture. Norway at this time is desperately poor. It's been ravaged by wars with England and Sweden. There's a blockade, which means famine. And in the middle of this, in the little village of Finnå, Niels Henrik Abel is born.
He's the son of a pastor, right?
Yeah. Yes, his father was a pastor. And his mother, Anne-Marie Simonson, is described in the source as a great beauty, but with, and this is a direct quote from Bell, general flightiness.
General flightiness. That's a very polite 19th century way of saying she wasn't exactly the most grounded parent.
It is, but despite the pinching poverty, and Bell mentions occasional empty stomachs, the family dynamic was actually quite happy. There's this charming image in the text of Abel as a teenager.
I love this part.
He's sitting by the fireside, researching his math with one eye on his book and the other on his siblings who are chattering and laughing in the room.
That's amazing focus. I can't even read a text message if someone is talking too loud next to me.
It shows his ability to detach. He could retreat into this abstract world regardless of the chaos around him, which, as it turns out, was a survival skill he definitely needed because his formal education did not start well.
No. He went to the cathedral school in Christiania, and frankly, it sounds like a house of horrors.
It was brutal. The schoolmaster was a man who believed in virile education, which essentially means he was a sadist. He disciplined students for the smallest infractions, and this is the turning point in Abel's life, strangely enough.
The darkness before the dawn.
Exactly. This schoolmaster beat a student so unmercifully that the student actually died.
Good Lord, that's just horrifying.
It is, but that tragedy forced the school board to step in. They fired the teacher, and they had to find a replacement. And the replacement was a man named Bernt Michael Holmboe.
Enter the hero of the story, or at least the mentor.
In many ways, yes. Holmboe wasn't a genius himself. He was competent, sure, but not brilliant. But he had a different kind of genius. He knew how to spot talent.
And he spotted Abel.
He did. Up until then, Abel was just an average student. But under Holmboe, he woke up. And here's the crucial thing Holmboe did. He didn't feed Abel the standard textbooks. He realized Abel was moving too fast, so he lent Abel his own copies of the masters.
We're talking the heavy hitters.
Newton, Euler, Lagrange. Abel didn't learn from secondhand summaries. He went straight to the source code of mathematics.
There's a great quote in there where Abel is asked later how he got so smart so fast, and he says, by studying the masters, not their pupils.
Which is fantastic advice for any field, really. Don't read the commentary, read the original work. By 16, Abel was digesting math that baffled professional mathematicians. He was fixing gaps in Euler's reasoning.
At 16, I was trying to figure out how to parallel park at 16, and he's correcting Euler.
And likely not solving centuries-old proofs while doing it.
Definitely not. So this brings us to his first big swing. The Quintic.
The Quintic. Yeah, this is the impossible problem of that era.
Okay, let's unpack this for the non-math majors. We all remember the quadratic formula from school, right? For solving equations with x squared.
Right, and mathematicians had found formulas for x cubed and x to the fourth. But for 300 years, the entire mathematical world had been banging their heads against the wall, trying to find a finite algebraic solution for equations of the fifth degree, the quintic.
So x to the fifth plus bx to the fourth and so on.
Exactly. They wanted a finite formula, a specific set of operations, add, subtract, multiply, take a root, that would just spit out the answer.
And Abel, being the confident teenager he is, thinks he's solved it.
He does. He writes it up and sends it to a scholar in Denmark. The scholar is cautious. He says, "This looks interesting, but can you give me a specific numerical example? Show me it works."
Show your work. The bane of every student's existence.
Precisely. And while Abel is trying to calculate the example, he realizes something terrible. His solution is flawed. It doesn't work.
That has to be devastating. He thought he'd cracked the code.
It would crush most people. But this is where Abel shows his true genius, and this connects to that theme of inversion we mentioned. Instead of trying to patch up his broken solution, he flips the question completely upside down.
This is the pivot.
He stops asking, what is the solution? And starts asking, is a solution even possible?
Oh, I see. He changed the rules of the game.
He proved that it is mathematically impossible to solve the general Quintic equation algebraically. He didn't just fail to find the answer, he proved the answer didn't exist. He closed a 300-year-old cold case at the age of 19.
19? That's wild. So he prints this up. He solved the impossible problem? Surely the world goes crazy for him.
You would think. But he had to pay to print the proof himself. And because he was so poor, he had to condense the proof to save on printing costs. E.T. Bell writes that he condensed it so tightly it became, and this is a quote, "God only knows how, difficult to read."
So he solves the impossible problem, but nobody can read the pamphlet because he couldn't afford enough paper.
Effectively, yes. It was dense, cryptic code. Gauss, the so-called prince of mathematicians, received a copy. The source says he saw the title, assumed it was just another crank claiming to solve the unsolvable, and threw it in the trash without reading it.
Ouch. That is painful. The answer was right there in his garbage can.
Yeah, it's a tragedy. If Gauss had just read those few pages, Abel's life might have been completely different. He would have been instantly famous.
So he's brilliant, he's broke, and he's stuck in Norway. He needs to get out.
He needs to meet his peers. He applies to the Norwegian government for a travel grant to go to France and Germany.
And the government, in their infinite wisdom, says,
They say, "We don't have money for a math tour, but we'll give you a subsidy to study languages." They wanted him to brush up on his French and German.
typical bureaucracy.
Yeah,
We won't fund your genius, but we'll fund your grammar.
he has to take it. And this leads to the tale of two cities part of his life. First, he goes to Berlin. And this is the one bright spot in the story.
This is where he meets Krell.
August Leopold Krell. Now, Krell wasn't a professional academic. He was a civil engineer. He actually built the first railroad in Germany. But he was a huge amateur math enthusiast.
And unlike the academics, Krell actually listens.
He does more than listen. He has the intuition to recognize that this shy, poor Norwegian kid is a genius of the first water. They became fast friends. Krell decides to start a new journal, the Journal for Pure and Applied Mathematics, which is still a huge deal today.
And Abel becomes the star writer.
He basically was the journal for the first few volumes. He just poured all his work into it, put the journal on the map. Krell championed him, introduced him around. It was a golden time. Abel finally felt seen.
But then he has to go to Paris.
Paris, the mathematical capital of the world. Abel expects to meet the gods. Legendre, Cauchy, Poisson. He thinks they'll welcome him as an equal.
But the reality is a little colder.
It's freezing. The French mathematicians were, as Bell puts it, civil but indifferent. They were obsessed with their own work. They just didn't have time for an unknown 20-something.
Let's talk about these villains, or at least the indifferent gatekeepers.
Well, you have Legendre. He was very old, in his 70s, polite but past his prime. And then you have Cauchy.
Cauchy is described as mad and muddled. Right?
Yes, Cauchy was brilliant but difficult. He was the only one really doing pure math like Abel, but he was incredibly arrogant. Abel writes these letters back to his friend Hombo, complaining about how lonely he is. He hates the noise of Paris, the bad meals, the high rent. He's just isolated.
And in the middle of this isolation, he writes his masterpiece.
The Paris Memoir. This is the work on transcendental functions.
Okay, expert mode on. Explain this simply. What did he do?
This brings us back to inversion. The source uses a brilliant analogy from Francis Galton to explain this concept generally. Galton wanted to study the link between poverty and drunkenness.
Okay, social science.
Right, everyone kept asking, does poverty cause drunkenness? But they couldn't figure it out. So Galton inverted it. He asked, does drunkenness cause poverty? By flipping the cause and effect, he could study the data differently.
So flipping the arrow of causality.
Right. Now, in math, people had spent 40 years studying the length of the arc of an think of the perimeter of a squash circle. These are called elliptic integrals. They were messy, complicated, just ugly.
And Abel flips it.
Exactly. Instead of studying the arc length, the integral, he studied the function itself. It's like the difference between studying a weird specific angle versus studying the sine of the angle. Sin 6 is elegant, periodic, beautiful. The angle itself can be messy.
So by looking at the inverse, everything cleared up.
Instantly. Bell says it was like clearing away Irish lace and French pastry to reveal a Greek statue.
Yeah.
He turned a chaotic mess into a beautiful structured theory. It generalized the entire field.
So he has this masterpiece. He submits it to the French Academy of Sciences. This is his ticket to fame, fortune, a job.
He hands it to the secretary. The referees assigned to read it are Legendre and Cauchy.
Oh, no.
Legendre complained that the ink was too faint and the letters were badly formed, so he basically just stopped reading.
The ink was too faint? Are you kidding me? He's holding a revolution in mathematics, and he puts it down because of the font choice.
That was his excuse. And Cauchy. Cauchy took the manuscript home, threw it on a pile somewhere, and mislaid it. He completely forgot about it.
He lost the most important mathematical work of the century.
Yes. It wasn't found until 1830, a year after Abel died, when the Norwegian consul had to badger the academy to look for it. Cauchy eventually dug it up.
That is infuriating. It's
Yeah.
just pure negligence.
It is. The academy eventually awarded Abel the grand prize for it, but he was already dead.
So Abel waits in Paris, hearing nothing. He's running out of money.
He's desperate. He eventually has to leave. He goes back to Berlin briefly, but he's too proud to tell Krell how desperate he is. Then he returns to Norway.
And now we enter the final act.
He returns to Norway completely broke. He had, according to the source, $7 left to his name, and he falls ill.
He thinks it's a cold.
He tells everyone it's a cold, but it's tuberculosis. He's coughing up blood, and this just captures his spirit. He keeps working. The source describes him in these final days as like a sick eagle looking at the sun.
That is a powerful image. He knows he's going down, but he's still looking up.
He's living in Froland with an English family where his fiancée, Krelly Kemp, is working as a governess.
And this part,
Mm-hmm.
the letter he writes, this gets me every time.
It shows his character. He knows he's dying, and he's worried about Krelly. She has no money, no family support. So Abel writes to his good friend Kielhau, and he asks Kielhau to marry Krelly after he's gone.
He's arranging her future happiness while he's dying.
It's incredibly selfless, and they did eventually marry, by the way. But Abel is fading. He dies on April 6, 1829. He was 26 years and 8 months old.
And the ultimate irony follows immediately.
2 days. 2 days after he died, a letter arrives from Berlin. It's from Krell.
Let me guess.
Krell had done it. He had secured a professorship of mathematics for Abel at the University of Berlin. It was a done deal.
So he died thinking he was unemployed, unrecognized, and broke. But if he had lived just 48 more hours...
He would have known that he had won. He had the job. He had the recognition. The world was opening up to him.
That is devastating.
It is. He died believing the struggle had been for nothing, when in reality, he had already changed history.
So let's take a breath. What does this all mean for us, aside from the fact that we should appreciate antibiotics and email?
I think the biggest takeaway is the power of that concept, inversion. Abel didn't have more resources than the French mathematicians. He had less. He didn't have better training. But he had the ability to look at a problem that everyone said was a wall and turn it into a door just by flipping the question.
You must always invert. That was his motto.
Exactly. When you're stuck on a problem, whether it's a math problem, a business problem, a life problem, don't just bang your head harder. Invert it. Ask the opposite question. Look at the data inside out. That was Abel's superpower.
I also can't help but think about the contrast between Krell and the others.
That's the other lesson. Krell wasn't the expert. He was an amateur, but he had curiosity and humility. The experts, Legendre, Cauchy, Gauss, they were so secure in their status that they became gatekeepers. They lost a masterpiece because the handwriting was faint. Krell looked past the faint handwriting and saw the genius.
It makes you wonder. The source mentions Gauss threw away Abel's work on the Quintic without reading it. How many other Abels are out there right now, sitting in a slush pile, ignored because they don't have the right credentials or the right formatting?
It's a sobering thought. Innovation often comes from the outside, from the people who don't know that what they're attempting is impossible.
Well, that gives us plenty to think about. To our listeners, take a look at that impossible problem on your desk today. Maybe you just need to turn it upside down.
And maybe double-check your spam folder. You never know what you might have missed.
Too soon. But yes, point taken. Thanks for diving in with us. We'll catch you on the next one.
Bye-bye.